Inside every single piece of modern technology, I'm talking about the phone in your hands, the computer on your desk, even the servers that are sending you this right now. There's a set of hidden ingredients. They're totally invisible to us, but without them, our entire digital world and even our green energy future would just grind to a halt. So, what are they? Let's dig in. Okay, so what in the world could possibly connect a tiny pocket-sized smartphone to a gigantic spinning wind turbine? It's not the software, and it's not the silicon chips. The answer is actually magnetic. It all comes down to tiny but incredibly powerful magnets. Now, these are not your average refrigerator magnets. Oh no. These are made from a special group of materials called rare earth elements, or REEs for short. You've got names like neodymium and dysprosium, and they are absolutely essential for everything from the little vibration you feel in your phone to the massive motors that power electric vehicles. Now, you might think these elements are found all over the globe, and you would be right, but here's the catch. Turning them from raw ore into the super powerful materials we need is a really complex process, and that process is overwhelmingly concentrated. Just look at this. Somewhere between 85 and 90% of all rare earth processing happens in just one country, China. So what does that mean? Well, it means we've got a massive vulnerability on our hands. Any kind of supply chain snag or geopolitical tension could seriously threaten the production of pretty much every piece of advanced technology we depend on. So as you can imagine, securing a stable supply of these minerals has become a huge priority for, well, pretty much everyone. And all this pressure has pushed some of the world's biggest companies to make a really big bet, bringing this critical part of the supply chain back home. And that bet? It looks a little something like this: $500 million. Yep, you heard that right. Apple is pumping a massive investment into building a brand new rare earth processing facility right in the heart of Texas. Now, this isn't just about building a factory somewhere else. No, this is a really strategic play. By building their own facility, Apple can make the exact kind of magnets they need. They get way more control over their own supply chain, and this is a big one, they can start folding recycled rare earth materials right back into their new products. It's a huge step. And this isn't some far-off dream either. They've got a real roadmap. After they get the buildings up and the specialized equipment installed, they're aiming to start initial production in 2027 and then ramp up to full capacity from there. But building new facilities is only one part of the solution. So building new plants is one piece of the puzzle. But what if a major source of these critical minerals isn't buried deep in the earth at all? What if it's already in our cities? Sitting in our junk drawers and old data centers. This is the whole idea behind a concept called urban mining. Instead of digging into the ground, we dig into our own piles of electronic waste, our digital landfills, to pull out the incredibly valuable materials that are locked away inside. And here's why this is such a mind-blowing concept. Our electronic junk is incredibly rich in these valuable metals. In many cases, it's way richer than the traditional ore we mine from the ground. Just look at gold. The concentration in e-wastes can be 40 to 50 times higher than in virgin ore. For copper, it's about 10 times more concentrated. It's literally a gold mine. Of course, the big challenge has always been, how do you actually get those materials out efficiently and cleanly? Well, that's where some amazing new technology comes in. A startup that actually spun out of the University of Texas is tackling this exact problem. Their innovation is it's remarkably elegant. They've developed a 3D printed cartridge that basically acts like a highly specialized sponge. It filters out the materials at a molecular level, but get this. Instead of using harsh, nasty acids, it uses simple, safe solvents like alcohol and water. And this kind of cool new tech isn't just stuck in a lab somewhere. Nope. It's already being put to the test in the real world through some really powerful collaborations. So check out this pilot program. It's a perfect example of what's called a closed-loop system. You've got Western Digital making hard drives, which Microsoft then uses in its huge data centers. When those drives get old, they're sent to recycling partners, who use new tech to extract the rare earths. And then, those recovered materials go right back into the U.S. supply chain to make new stuff. It's a perfect circle. The technology that makes this all possible is called acid-free dissolution, and it's pretty brilliant. Instead of bathing everything in harsh chemicals, it uses a special, much gentler solution to selectively pull out only the rare earth elements from all the shredded hard drive bits. It's way more precise, efficient, and so much cleaner. And the results? honestly, they're staggering. This new process leads to a 95% reduction in climate-changing gases compared to making the same materials from brand new mining. 95%. That is an absolute game changer for building sustainable technology. So when you look at the whole picture, this pilot program just knocked it out of the park. They recovered over 90% of the rare earths inside the old drives, the final product they created was over 99.5% pure, and they proved that this whole thing can actually make money and be scaled up. It just works. So, with these incredible advances in making things at home and mining our own e-waste, you might be thinking the supply chain problem is solved, right? Well, it's important we look at the whole picture. It's a little more complicated than that. This quote right here really brings us back down to earth. One analysis puts it bluntly, even if we were perfect at recycling every single device, the amount of material we could get back just can't keep up with how fast our demand for these minerals is growing. And this chart shows you that challenge in really stark visual terms. The International Energy Agency projects that our demand for these minerals could go up by 30 times by the year 2040. 30. And at best, urban mining is only expected to supply maybe 10 to 15% of that total need. That is a massive gap we have to fill. So here's the bottom line. Urban mining and domestic recycling are absolutely 100% essential. No question. They make our supply chains stronger, more secure, and way more sustainable. But they are a vital supplement to, not a total replacement for, traditional mining. To power our future, we're going to need both. Which leaves us with the ultimate question, doesn't it? Our appetite for new, faster, better technology is just growing at an exponential rate. And as we build this new, more circular and sustainable material reality, the biggest challenge of all is going to be a simple one. Can it scale fast enough to keep up with our own ambition?